Good morning, everyone. I am Dr.Remila, Assistant Professor, Science and Humanity Department, Emmanuel Arasar, JJ College of Engineering, Natala. The today's topics surface tension and related experiments. First, we are going to discuss about the topic surface tension. What is surface tension? The force acting per unit length along the surface of a liquid perpendicular to an imaginary line drawn on the surface is called the surface tension. The force acting per unit length along the surface of the liquid perpendicular to an imaginary line drawn on the surface. The formula is surface tension equal to force per length. The unit is Newton per meter. Okay, the unit of the surface tension is Newton per meter or Newton meter power minus 1. Then the examples. The examples of surface tension. The first example, I explain the first example. Water droplets form a nearly spherical shape because of surface tension. Water droplets form a nearly spherical shape because of surface tension. It also allows small insects like water sedges to walk on water. This is the first example. Then next another example of surface tension is a needle can float on surface of water if it is placed carefully. If a needle can float on the surface of water if it is placed carefully. The surface tension of water supports the needle and prevents it from sinking. Okay. Then the another example. Soap bubbles have thin spherical surface. Okay. The surface tension formula is force per length. F means force acting on the liquid of the surface. L means length of the surface. Okay. Next, this diagram represents the surface tension by capillary rise method. This is the first experiment. The first experiment is surface tension by capillary rise method. First, I know surface tension. What is surface tension? What is the formula for surface tension? The surface tension formula is force per length. This diagram represents the surface tension of capillary rise method. Okay. The apparatus are capillary tube containing the beaker distilled water, traveling microscope, stand and clamp. Okay, traveling microscope in left side, stand and clamp, beaker with distilled water, then capillary tube. These are the apparatus. The aim of the experiment to determine the surface tension of water using the capillary rise method. What is the aim? To determine the surface tension of water using the capillary rise method. Okay. Then the apparatus. Okay. The principle. What is the principle? When a clean capillary tube is dipped into the water rises in the tube due to the surface tension. When a clean capillary tube is dipped into the water rises in the tube due to the surface tension. The height of the liquid column is measured and used to calculate the surface tension. Okay. What is the formula for surface tension? The capillary rise method. The T equal to RH rho G divided by 2 cos theta. This is the formula for capillary rise method surface tension. R means the radius of the capillary tube. H means the height of the liquid rise. Rho means the density of liquid. G means acceleration due to gravity. The value of G is 9.8. The theta means angle of contact. Okay. Then procedure. Fill a beaker with clean water. Okay. Fill a beaker with clean water. Place a clean capillary tube vertically into the water. Place a clean capillary tube vertically into the water. Allow the water level in the tube to stabilize. Allow the water level in the tube stabilize. Then measure the radius of the capillary tube. Finally, substitute the values of the formula to calculate the surface tension. The surface tension formula is T equal to RH rho G divided by 2 cos theta. Okay. Then once again I repeat the procedure. Fill a beaker with clean water. Place a clean capillary tube vertically into the water. Allow the water level in the tube is stabilized. Then measure the radius of the capillary tube. Then finally substitute the values into the formula to calculate the surface tension. The surface tension formula is T equal to RH rho G divided by 2 cos theta. R means radius of the capillary tube. H is the height of the liquid rise. Rho is the density of the liquid. G is the acceleration due to gravity. Theta means angle of contact. Finally, calculate the surface tension of capillary rise. Okay. Observation. The water rises in the capillary tube due to the cohesive and adhesive force acting on the liquid. Then the result is the surface tension of water at room temperature is approximately 0.072 Newton per meter. Okay. The surface tension of water at room temperature is approximately 0.072 meter. Then the precautions. What is the precautions of surface tension of the capillary rise method? Use a clean grease-free capillary tube. Keep the tube perfectly vertical. Take readings at eye level to avoid parallax error. Use distilled water for accurate results. Okay. These are the precautions of capillary rise methods. First one, use a clean grease-free capillary tube. Keep the tube perfectly vertical. Take the readings of eye level to avoid parallax error. Use distilled water for accurate results. Okay. Then I will explain the second experiment is the determination of surface tension by drop weight method. Determination of surface tension by drop weight method. Okay. What is the aim? To determine the surface tension of the liquid by the drop weight method using the stalagmometer. Means that is means drop weight apparatus. Okay. Stalagmometer means drop weight apparatus. Aim to determine the surface tension of a given liquid by the drop weight method using the drop weight apparatus. Okay. The apparatus required the stalagmometer, distilled water, test liquid, beaker, weighing balance, rubber tube, stand and clamp. Okay, this diagram represents the surface tension by drop weight method. Okay, the principle: a liquid drop falls from the tip of the drop weight apparatus when its weight becomes equal to the surface tension force acting around the capillary tip. Okay, the procedure, this diagram represents burette fully filled the fluid. This is the digital thermometer. The procedure: first clean the beaker fully and dry it. First clean the beaker fully and dry it. Fill it with the distilled water above the upper mark. Fill it with the distilled water or any fluid. Fill it with the distilled water or above the upper mark. Then allow the liquid to flow slowly and collect a known number of drops in a weighted beaker. Example, you take 50 drops. Okay. Then the weight of the beaker with collected the drops and calculated the total weight and average weight of the one drop. The weight of the beaker with the collected drops and calculate the total weight and average weight of the one drop. Repeat the experiment with the test liquid using the same number of drops. Repeat the experiment with the test liquid using the same number of drops. Then repeat the experiment with the test liquid using the same number of drops. Finally, calculate the average weight of one drop for both liquids. Then determine the surface tension of the liquid using the formula. Finally,